Okay, right. Yeah, now it's all working. Make sure the audio is working as well for the system. Okay, we are good to go. And now just gotta sort out the playlist. Right, hopefully this is a good playlist. So let's have a look. Okay. Let's get back to what we were doing last time. So let's take a look at the code and see where we stopped. So what have I done, essentially? There you go. In the past few days, I actually added support for Boost Lockfree here. So essentially that's a library that contains a few data structures that are lock-free, lock and wait free, such as the ring buffer that they have. It's called the SPSC queue. And essentially it's a ring buffer with an allocated amount of bytes where we're going to be using that queue for queuing basically audio frames into the device. And the reason why it has to be that particular data structure is because all of the stuff that happens inside the callback here for PortAudio has to be fairly fast, and it can't be sort of undeterministic in a way that you won't know whether or not you're going to be waiting on another thread or locks or anything like that. So this is the reason why we use a lock-free queue, and I'm hoping that that we're going to get this code working today. So let's try it. So what did I do here actually? So essentially I modified my VCC, my VC package.json to include the Boost Lock-free module. And again, that's a particular submodule of the entire Boost ecosystem that contains all the lock-free structures and all the dependencies of that module. So we included that in here, which did cause the compile times to go up a little bit, especially on the CMake configure stage, because CMake is going to try and look for Boost and lock-free, and if you don't actually have that already in your system, if let me just turn it down a little bit. So yeah, if Boost is not already in your system, it's going to build all of the stuff needed for lock-free and lock-free itself, so that does take a while. But this is better than including the whole of the Boost library. And this is a package you can find in the VC package website. So if you look at the packages here and you search for Boost, for example, you are going to find Boost and then all of its submodules as sort of one VC package recipe. The one I'm using is the lock-free, so let's see if we can find that so you can see. Give me a second, it'll be there soon. See, Boost has a lot of functionality, so it has a lot of modules, as you can probably tell here. Lock-free, this is the one we're using, and in particular we're using version at least 1.8. So let me just make sure that I'm not really too quiet compared to the music. Now we can turn it up a little bit, can't we? So there you go. I think that's probably a little bit better, isn't it? Let me also keep an eye on the chat. I've also got my hot chocolate here, which I'm going to be sipping. So let's go back to it. Okay, once we modified the VC package manifest file, obviously when you configure CMake is gonna, VC package is gonna provide you all of these boost targets, such as the one we're actually using in the audio library. It's called boost -- boost, and I believe I can actually just do Lockfree in this case. So let's see if it works here. I just want to include the Lockfree, but let's see if that's gonna work. I think I tried it before and it didn't quite work. So you can see, yeah, there's an error somewhere. Target audio demo links to target boost Lockfree, but the target was not found. Yeah, I mean, this is interesting, isn't it? Because essentially I have to link against the entire boost ecosystem, but I mean, it's fine. We'll sort this out later. Let's not worry about it for now. Just link to the whole of boost and whatever is available in that target. So yeah, I mean, once you change the CMake lists to include that, so that includes, you know, adding the find package call here, and also the target link libraries, we add boost colon boost to it, and that gives you access to the boost headers. So in our particular case, where I'm using the stuff in the audio library, you can see that I'm including boost Lockfree in both the header and the CVP file here. So these are the headers I'm using. So I'm using SPSEQ, which is that ring buffer I mentioned, and policies, which contains some of the capacity stuff, I believe. Yeah, but I'm not too sure actually. I think I can just go without that header. So the changes I've made are actually quite simple. So in P8 stream data, I left the left phase and the right phase floats that are basically tracking the current frame position, so the current audio wave, if it makes sense, the current audio point. Left that there for now, just to still compile the code. But I've also added these two queues here, so you can see this is a boost Lockfree single producer, single consumer queue, which is that ring buffer that I mentioned. I don't want to go too much into detail about this because it's actually quite an involved structure, and to be honest, I need time to actually read it and understand it properly. All I know is that it can potentially be lock free and wait free, so I'm trying to see if it's going to work fine. So as that queue afloat, and I'm also saying that this is going to have a capacity at compile time of 512 floats, okay? Which is kind of twice what we have for our buffer, right, when we initialize it. So yeah, it's 256. So 512 is twice that value, which should store, you know, enough data points for our audio. So okay, so that was added to the PA stream data, which is the type of data that I'm passing to the callbacks every time. And what I actually have to change now is the create default stream. So the create default callback function, or the default callback function. It doesn't create one; it is that callback itself. So in here, we actually have to say, you know, I actually have to make the logic work. So basically, what I want to do, and I'm going to delete all of this so it doesn't get too confusing. What I want to do is basically to go through those two queues that we have. So I think it's called data left is one of them, for example. There's a nice function in the Lockfree queues. I think it's called read available or something like that. And this returns you the number of items that you can actually read or are available to be read from the queue in a lock-free manner. So let's do that. And basically what we want to say is that whenever this has exactly 256 items, right? That's what it is, yeah. So when it has that, the whole buffer for the audio that we want, which is, you know, 256 elements, we're going to read it, and we're going to pass into the audio device. So let's do that. So if the left channel is available to be read completely, we're going to actually say that now this is interesting because I just realized that the data here is interleaved. What does that mean? That means that every sort of even element, so starting from 0, is going to be a frame in the left channel, and every other element starting from position 1 is going to be a sample on the right channel. How can we do this, right? Okay, so let's actually make this condition, make things simple. If one of them, both of the channels are available to be read, they're both available to be read, what we can do is a for loop here, simple for loop. That's going to shadow this variable, isn't it? Into I can delete that from there. So starting from 0 and going all the way up to the frames of the buffer. And we're going to increment here. Now just this logic that we have up here really, so I'm just going to copy and paste this code. This is at the current state, how we can put data to the audio device. In other words, by copying data onto the output buffer, and that's what this out represents here. And this is something I acquired from the default, sorry, the example code from PortAudio. I've just refactored it a little bit, not much. So data left. So right, it's going to pop one from the left, and pop one from the right. Okay, so essentially, you know, we've got it good here. So this is essentially what we want. Just read from the queue. I am going to actually bring this code around a different function. You see what I did there. Let me just touch. Let me just oh, my dog. Is it fine? Yeah. So, you know, I'm gonna create a new function that's gonna generate perhaps a vector of some sort with some with the square waves. So let's do that. This is very lazily, you know, done. Just so we can test this new queue code, so we can see if we, you know, we pass in the data from this square wave function into my queues, if it's going to work. Basically, that's what I'm trying to do. I think I had something like this, right? And also, I'm not sure if we have to, but you know, if there's no bytes to be read here, if there's no audio samples, we should probably set the outputs to 0. In other words, there's no audio at all. That's something we may want to do. I'm not sure if this output buffer is already going to be initialized, you know, everywhere with zeros. But I kind of have a suspicion that it's not, so it might give us sort of like white noise. So, but we'll see. Now that we've got some code in main that already does that, perhaps we should actually put this code in main. This is part of the main program, isn't it? This is actually creating the audio that we want. Oops, I forgot to copy it. And if we go back to main, add it to here. Because we've got that frequency there. I think I need this code that calculates all of the stuff we need to actually create the correct audio wave. So if I wanted to create a vector that has basically audio samples or a channel that will play a particular square wave for an exact number of seconds, how do we do? And in fact, you know, let's call it milliseconds or something. Well, we know that we have this many samples per second, right? So how many samples do we need? Start it. Like this. This is 420 divided by 1,000 because we're working in milliseconds, and times the number of milliseconds we have, right? Because if you look at it, if you have 1,000 milliseconds, in other words 1 second, you're going to have exactly 44.1k 1k samples, which is what we want. So how many samples? So number of samples. That's better. So we need this number of samples. So we know for a fact that we're going to need something like, you know, for I0, and less number of samples. We're going to need this here. We'll be adding onto our vector. Obviously this step will be, you know, still calculated up here. Why is this failing now? Yeah, so I think this is still the correct calculation, right? Because we want to know how much we have to increment each sample by on every iteration here, so we can get exactly, you know, however many square waves we need per second, and that's the calculation I did last time. I'm just going to trust it. I think it's exactly actually the amplitude, which is in our case is 3, I think. Yeah, cool. So what we do is the following. Before we do anything, let's turn this actually a little bit faster. Sound wave or reserve. We're going to need this number of samples here. The starting value will be zero, right? So put a sound wave, back or something. And what I can do here is something like something like that. Current is more than or equals to, I think it's 2, right? That's what it is on the original callback. More than 1, yeah. So it goes from minus. The PortAudio is a bit funny. It goes from -2 to 1. So basically, if we get to this, then we say, current is now back to -2.0. At least that's what they have in the example code. Hello, Miguel. I can see you there. How's it going? Another late night stream for me. Long time no see. How are you doing? Almost 3 days because of my internet service. Oh man, I can feel your pain. Yeah, I hate when my internet goes down as well. I absolutely hate it. My life is on the computer. I like being on the internet all the time. Well, on good news, this code actually outputs some audio to Space Odyssey. So I'm just doing some final touches on this, and hopefully you've been reading about atomics again. Oh, that's interesting, yeah. So I was actually doing some reading on Lockfree and atomic programming and myself. I wanted to use something called the Lockfree queue, and I ended up using something from Boost, but I did a lot of reading on atomics and how to implement that sort of structure with those simple atomics. So yeah, it's definitely interesting, isn't it? It applies for audio quite well, because in audio, for the audio callbacks, the code that's actually generating the audio samples for the devices, you can't have any locks or any code that's going to take a long time potentially. So this is where atomics and Lockfree comes in. Which is exactly what I'm using it for now. So hopefully I'll finish some code now so you can actually look at what it does. So this should be okay now. Why is Vim hooking up? This is something we can definitely refactor later on. I don't really like the code I'm doing here, but it is what it is. Undefined behavior is really scary for what I read. Yeah. Depends on what you're doing. It's scary because you can't really debug it. You never know where it's gone wrong. So this is where things like data raises. Can you make it louder? Yeah, I can make my audio louder, I think. Let's see. Is it better now? Oh. Hello, testing. I'll see if I can apply my my microphone is on loudest, so let me know if you can hear it. I can close the door and talk louder as well. 1 second. Is it better now? Let me know if it's better. Yeah, my microphone is already on loudest. I mean, it's definitely gone louder now, but so yeah, the idea in this particular case is that's going to disappear. The idea is that we have the audio streaming here. We can also call, now let's call this function that we create the square wave. Now Miguel, if you don't know what square wave is, I hope you do. This is what a square wave is. Where is it? It's this here, and it creates a very particular sound when you play it. So, you know, if you remember very old games like the Atari and stuff, they would have used, you know, square waves like Pong, for example. Pong is a great example of a square wave, I think. That, you know, the noises in the game Pong from back in the day, those were square waves. So this is what this code is doing. It's creating that. So I used to hear a lot about, yeah, 8-bit music is good. So what do I need in this here? I think I want to play 2 seconds of some note. I don't know which one. Let's take a look. Which frequency do we want? 52335. 52325. I mean, let's see if this actually works in the first place. So, for auto sample in wave. I'm gonna push this data to both left and right. What do we do? We're gonna push. Yeah, so I think we're just going to push into the queue. After that, we'll have a wait here. So that's this thread, big 4, and then let's say we want the chrono. So I'm pushing that sample into the queue and then waiting 5 seconds, let's say. this code should compile, at the very least. Now let's see if we can hear anything. No, it didn't compile. What happened here? Type floats, unexpected. Okay. They have to be the same type. Okay, let's compile now. I thought that syntax would work in C++, but clearly I'm a noob. Okay, so let's run it and see what happens. Right, so there's definitely some errors. Access violation, reading location, and something. So this is not good news. Let's look at the stack here. Where is it coming from? I mean, main thread. What was the last thing we called? So this thread, we're here basically. So there's definitely some code, something wrong in the Q code, I think. So let's take a look. I am probably not going to figure it out straight away, but we can look at it. See, this is the kind of undefined behavior you're talking about. So what do we do, mate? We create a wave and then we pass it to the data. The stream has already started. And while this happens, it's going to be doing my callback, which is essentially, you know, the default callback here. And, you know, we can see if this is kind of running. I'm putting a breakpoint here. Ooh, I'm going to put the music on again. Oh, it's running. So I know it's gone here. Okay, so we're not writing anything. You see, it's the data. And this is where the exception happens. Wait. Why is this code there? There you go, that should just be an if statement by itself. Try again. I know it's probably not going to work, but... Okay, so this is definitely writing some stuff because it is available now. It's kind of just popping the audio. I'm not sure if you can hear it, but... Try that again. Yeah, it's not doing much. I want to see what the buffer looks like after it's written to. Okay, so basically here, what can we see? We can see the out. To the binary data, binary X. Okay. Okay, why not? Okay, so this is what the buffer looks like when it's written. Ooh. It's mostly zeros and then it goes up and down. But they should both be the same, like left and right. So these two are the same, these two are not the same. These two are not the same. These two are not the same. So there's definitely something wrong here. Ah, there you are. It's because I'm trying to pop it. There you go. Now they should both be the same. If I just put, sample. Yeah. Let's try again. Now at least they should be the same. Okay, so since we're here, let's go to the debug console, type out, and then 2 and 513. They are the same, they are not the same. They are not the same here. So yeah, this is not looking promising. Not looking promising at all, but yeah, I can't hear any audio, so not working. Let's figure out why. But just for the sake of interest, we have the left and right pops. Do we write to those? Yeah, we push the sample to both of them. And at this stage, the callback should, happen. Let me just see again. Right here, the callback is going to happen, right? Or maybe not. So we sleep for 5 seconds and then the callback happens. And then we go into this. And we should have left and right here. They should be the same sample each. Just so I can see what's going on. I'm also going to copy those in here. Go left and right. Have that. Do I not have the array for a second? I don't. So are those two queues? So, right, good question. So data left and data right, they are queues. Yeah. So they are actually this type here that I've created to passing data to the sound callback. And these are queues, yeah. These are boost queues. Remember when I said lock-free queues that I was looking for? These are the lock-free queues. So I'm basically setting data from the main program onto these two queues. And you can see it here, data.left.push and data.right.push, my sample. I'm setting them both in that data, that user data struct, because then my callback can see what's in there. So the idea is whatever I set in there should be creating some good audio. But all I can hear is a popping in the speakers, so I don't think it's working very well. So, which is a shame, but I'm gonna try and figure it out. So let's go back to the audio code. Let's try and compile this, and I want to see what's going into the these queues now, or what's inside the queues when I receive them in the callback, because I'm not too sure. So yeah, let's run it. And this is why I created these arrays, so I also replicate whatever values go into my audio inside the array, so I can look into the array and see. Okay, so we sleep, and the callback's happening here, and it's going in now, so I should be able to put a breakpoint there and look inside my arrays. So this is, there's all zeros there on the left, as you can see, and all zeros on the right, I guess, which is not right, obviously. I mean, it should be, values going from 0 to -2 to 1. Now the question is, why is this returning me zeros everywhere if I'm setting them a main? In fact, I'm sensing them here. Is my wave returning zeros everywhere? So let's take a look. That's probably what's happening. So I have a function that creates square wave, so I'm wondering if that's creating the right stuff, if you see what I mean, because that could be wrong. Okay, so my wave, what does it have inside? It has some meaningful data. So let's actually go down to here, where data left and data right should have, you know, samples in it. And they look like they have some data. How many files is here? It's 512 times 4. I think it saves the actual bytes. 512. Yeah, nice. 2048. Is that how it works? It saves the bytes of the floats instead of the actual float values. That's interesting. 2048. Has a few more than that actually. Interesting. It should have stopped there, but it has an extra element, which I guess keeps the pointer to the element or something. I don't know. It was interesting. Okay. So before I set it, what does it start as? Is it all zeros? Okay, so before we do anything, what is this? So yeah, these are all sort of zeros everywhere. And then it definitely does change down here. Yeah, definitely does change, doesn't it? And then when he gets the callback, the data should be there. Oh, okay, I see. That's a mistake. Pop doesn't actually return the value. Ah. Okay, so it returns true if the pop operation is successful, false if the ring both was empty. No, it's thread safe. So I wonder where the element went to. So how do I actually pop from this queue? There's a misconception by me. It's P and C. Examples. Just look at examples. Pop. So we have a consumer. Wait, the boost queue class implements. This is not the class I want. This is not the class I want either. This is the one. So while consumer count is there, I guess pop takes a value and it will store the value in there. Is that correct? Yeah, okay, so there is, yeah, if I want to actually pop the value, I have to pass in the stuff. Okay, that makes more sense. So here, what we can actually do is data left and a pop. And then we can pass in a reference to this. Okay. We're going to do the same thing, go right. This song is very bad, I'm sorry. Yeah, see, it's always the documentation. When you don't read it properly and you assume things, you always get it wrong. So, anyway, we've got a left pop and a right pop. And ideally, really, because this returns a boolean, I want to make sure that they both, you know, if they didn't return, then we would return something like, you know, 1 or whatever. Really don't want to stop the audio, so I'll probably still return 0. This indicates a pass, I think, in this. Okay, this is essentially the code that should work, right? So let's compile and try again. Okay, so we create the wave here, passed into this, and it goes into here perfectly. Oh, there's quite a few of these. Okay, so it returns false. There's another issue. I think the issue here is that the frames per buffer. I mean, that goes in there, surely. Let's see if it ever returns any of these. We weren't able to pop anything here, and why? Why is that? At this stage, we do know that there's at least 256 available to be read. There's nothing wrong with the logic, right? Yeah. Does it always happen? I wonder if on the main I'm actually setting this to interesting. So read that, there was definitely more than enough available. The first pop gets read, but then the second one fails, and that is because, yeah, that's my fault. That's because of the exclamation mark, can you believe it? We should read something like, you know, if this doesn't succeed, hence the exclamation mark here. Which on the first one it was correct. Now let's try again. Let's read the square wave, went in there, went in here. And then we're actually going to return. We did. What is on right? No, still zeros everywhere, unfortunately, which is not quite right. What's on left? Also zeros. Not okay. It makes a noise, doesn't it? So, square wave seems to be working. I don't know why, if I'm honest with you. Yeah, because out should be basically... I mean, this should be assigning some value to it, but let's see if we can figure out if it's got some stuff in it. Okay, so But it's not going into here, right? This opens a shit ton of consoles, dude. What the fuck? Okay. Is this better now? Okay. Okay, so let's take a look at the debug console and look at the output. I thought it was my phone. No, it's the coding here. It's PortAudio. I'm sorry about that. It's generating a square wave for the note C at the frequency, I think it's 523 or something, so it gets better soon, don't worry. Still seems to have gibberish though. These are the same, 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 these are the same. It doesn't look right either. Maybe the debugging has been a bit bad. Maybe at this stage, I don't know if it gets written out or something. I don't know what is reading the out. So what we can do is we can call it something like float sample. Something like this should work, right? Yeah, it takes the reference, cool. And then here as well, we're gonna do the same thing. Let's see if we find anything interesting here. Okay, so create a wave, sleep. Go in here. Okay, this is better. So this is actually what goes into the out, which is good. Definitely good, yeah. Cool. So there you go. Okay, cool. So that runs for about 2 seconds. Right? Yeah, so this will get interesting. It just keeps going, doesn't it? Should only be 2000 though, 2 seconds. So if I generate my square wave, this code here can go, basically. I'm hoping that it'll be shorter now, the amount of time it plays for. There you go. Still plays for the whole amount though, but why? Yeah, it's definitely a number. It's definitely there. And the step will be the same frequency. Hmm. I wonder if this math is actually correct. Yeah, I think this math is correct. Let's see if the sound waves return. You know, in this particular case, it should be capacity 4400C. Not quite right though. Debug console. That times the milliseconds. Okay, it's because it's doing integer division. Integer. Okay. See, very slight bugs that you don't normally notice when you're writing code like this, but I see the capacity. Yeah, no, this is a lot better now, you see. It's a lot better because the number of samples is actually correct. So it does give me 44.1k samples. Now, if I then come here and say I want a 2-second audio, I'm expecting 88.2, right? K sample. So let's take a look and see if that's what it actually does. Yeah, so this is good. This is definitely good. So at least we know this code is doing, you know, what it should be doing. And it pushes all of the samples onto the queue itself. Which we know is not quite right because it should only push like 512 at once, right? Yeah. Unless we wanted to make the queue hold a little bit more than a sample. I'll put it for 10 seconds as well, 10 seconds. Jesus. This is not right. This is not right at all. Yes, Miguel. Not sure if I'm going to be able to fix this today. I mean, at least we got the infrastructure quite there, right? It does push some data to the queue and you receive some data, I guess. But it's interesting that it doesn't work. Ooh. Getting tired. What we should do as well is something like, you know, make sure there are enough bytes to be ready to be written. Or something like, you know, if the data got left, but writes available, It's more than 256 or something. And I kind of think as well that we're gonna have to basically take this and put some really high values, so 1024 for example, so we can hold a few buffers at least, because then we can write like 512 every time. So we write 512 bytes at once. Basically, we want to write a few chunks, but one chunk at a time. How can I do this? Get it more complicated the more I think about it.
Must be implemented. New extermination methods are under study.
Alright, this one is okay to wait for audio. Right, vector. Enough bytes to write. Can we do this? Because we did this, we can say in chunks. There's one less. We might be missing a chunk here. I don't know. We don't care about that for now. So we need a sample here. unfortunately that's going to come from my vector. Where are we? No, the math's complicated as fuck here, but oh well. Is this just a for loop? Have I just really overcomplicated the for loop? I think I have. Oh well, this could have been done in the same way as kind of like this. I'll leave it as a while because I need little chunks as well. And chunks written. Yeah, I can do. That's a good shout. I can use the chrono, the chrono stuff, the chrono literals, I think they're called. You know, it's same thing as color. Yeah, it does. It does work for milliseconds. You can do something like this. Chrono literals. That would work as well. In fact, that would just, I believe, that would just pull in the seconds and the milliseconds and stuff. But yeah, I can do this. I believe, right? Namespace is not allowed. There's a way to namespace, std literals, chrono literals. Oh yeah. It is the right name. The user namespace, chrono literals would work fine as well, I hope. Yeah. That would do the same thing, you know. Down here I can put 10 seconds. Yeah, chronoliterals would be, I think 14 actually, or even 11. Not 20, 20. He was out a little bit before that. This is too much, isn't it? That's 10 seconds. Right, what I think is happening is yeah, this is something weird going on. It's not playing for 2 seconds, is it? It might be something with the audio callback. Or the way I initialize PortAudio. Yeah. There you go. That was... Okay. That makes more sense. Well, it doesn't because I haven't compiled, but I'm pretty sure. You know, if we take a look at that, what does it create? Default stream, which calls PA stream. Create open default stream. This one here, right after the sample format, we have the sample rate. And that was 10 times less than what it should be. No wonder why it sounds so shit. So hopefully we'll get something a little bit better now. Ooh, there you go. Much better, isn't it? And I think that code kind of works. They should play 2 seconds. Let's try again. Okay. There you go, 2 seconds, more or less. Now if we do 4 seconds, does it work? I didn't because I didn't compile it. Yeah, it kind of works a little bit, doesn't it? A chunk is not gonna do much. Well, this is good. I mean, I need to obviously refactor all of this. what is interesting now is that I can take all of this code here. I can create basically a big vector full of square waves for my sound here. So let's do that. Let's see what happens, shall we? So Space Odyssey is what we have there. This is the cherry on the cake, Miguel. It will actually sound pretty good. Watch it. What does that take? That takes no ID. What is this? Say no to ID. Oh, okay. Okay, so we have the wave here. Okay, so we should we're gonna insert at the end. Okay, should work now. And we have the whole song we create. Instead of my wave down here, we're gonna have the whole song. And we're also gonna have the whole song. Let's see if it compiles. Shall we take a look? There you go. That was supposed to be the ta-da moment. So hopefully you enjoyed it. It's Space Odyssey. That's what it should be. It's one more time. There you go. Space Odyssey in square waves for you. And it's interesting that we can actually divide those notes by 2. More or less, and then end up in a lower octave, for example. A nice maths property of audio. There you go. My mom was like, what was that? Sorry about that. It's the from the kitchen. Yeah, my dog is down here looking at it, trying to find out where it comes from, but it's a very popular song, a very popular theme song from Space Odyssey. Right, Miguel. I think I'm gonna leave this stream here, and it was amazing talking to you again and having you watch me code. I'm gonna clean up this code tomorrow though, because it's a mess now. But at least, at the very least, we got an audio queue working, and I've got some code that will push. Yeah, thank you, thank you. I've got some code that pushes some audio or some data into the queue, and it doesn't seem to completely break, which is good. So I'm gonna actually push this before we go. And then I'm gonna call the stream. I think it's what we need, yeah. Okay, cool. That's it, Miguel. Hasta luego. I'm gonna have a buenas noches here. So I'll see you soon, man, and have a good night. Yeah. Here in the UK is already like 12:30, and I guess in Argentina it's like 9:30. So, but anyway, man, see you and bye bye.